Alrighty, nerds. We're finally day 4. Gonna finish transformations. Thank goodness. Sick of these things. Alrighty, transformation of a piecewise function. Guess what? We already did this in these notes. It was a long freaking time ago for us, but there it is, right there. This is piecewise, and here's us transforming the crapola out of it. So we're just gonna do it again. For fun, I guess. Let's talk about what transformations are going on. This one right here, what's this telling us to do? And we can use normal words. What's that? Yeah, go left 2. So this says shift left 2. And, you know, we would have to say horizontal translation, -2 units, whatever. But well, you know it's going to go left 2. And what is this going to do?
Down 3.
Down 3. Left 2, down 3. That's it. So go to each one of these dots and go left 2, down 3. So it looks like this one will be at, you know, it'd be a lot easier to, oh, it won't fit on this grid. I was going to say, I'll just draw it on here, but it won't fit. So we go left 2 to -6, down 3 to -2. -6, -2 is here. Left 3 to 1, 2, 3, -5. No, down 2 might be, what's left 2? Down 3. All of a sudden, I'm stupid. Anyway, -4, and then go down from -1 to -4. So -4, -4? Yes? All right. -4, -4. That doesn't look right. Hold on a second. Left 2. Down 3. So -6, -2. Oh, that's why I put it on -3 by accident. That's just because I can't see. Sorry. I was like, something's not right here. Anyway, try this one more time. Left 2 puts me at -4. Down 3 puts me at -4. So -4, -4. There we go. You see how this one's 1 unit to the right? That's not going to change because there was no stretching or shrinking. See how from here to here was up 2, right 2? That's not going to change because there was no stretching or shrinking. So we really could have found this one coordinate and then just followed slopes because shifting, and it doesn't matter which way we shift, all shifting are rigid transformations. So even our slopes are preserved. So we can go up 2, right 2. Go up 2, right 1. Right 1, down 2, and down 1, left 1. There it is. See, that's a nice thing about rigid transformations. There it is. We've already done those. Easy question. Easy peasy, right? What about words? Boop. It says take your function. Here it is. And we want a write the equation for the graph of the function k is a multiplicative transformation by a factor of 3. That literally means take all of your function's values and multiply them by 3. As if you were going to put a 3 on the left side here. If you did this, 3 times your f of x, and you multiply the left side by 3, well, by golly, you better multiply the right side by 3. So how do I make sure that I capture the entire right side?
Put it all in parentheses.
My man, parentheses. There it is. It says call it k. So this is k of x. Red and blue makes purple. Here's k of x. And then just distribute the 3. Ta-da. That's it. What's that? Because I messed up and wrote a 3 by accident. Because I saw this 3. Good catch, though. By the way, changing an exponent is not a transformation. It's just a oopsie-poopsie. Yeah. No, changing an exponent is never a transformation. So that should never happen. Changing an exponent changes the curvature. So It creates more maximas and minimas, and it's not a transformation. Not at all. But that's it. So instead of saying a multiplicative transformation by a factor of 3, they could have said vertical dilation factor 3. It's just words. As long as you know they mean the same thing, you're in good shape. Anybody stressed out about it? Nobody said yes. So that means nobody is stressed out. The table gives values for a polynomial function at selected values of x. Here's what we know. G of x is some kind of transformation of f of x, where a, b, and c are positive constants. That means there's no reflecting. Okay, recording again. What was I talking about? Oh, yeah. There's no reflecting because we know that a, b, and c are positive numbers. So we've got some vertical dilation, horizontal dilation, and a vertical shift. The graph of G is constructed by applying 3 transformations in this order. Horizontal dilation of factor 3. We don't have a equation for G of x. So down here when it asks me to find G of -6, I'm not just going to be able to plug in -6 into an equation for G. Well, at least not the kind of equation you're used to having. You see, what we do have is some function representation using transformations for G. So if we can get the appropriate numbers for A, B, and C, we could plug in -6 to that. So let's talk about this one. Horizontal dilation factor 3. Horizontal inside or outside, guys? Inside. And we can see there's only one thing inside. It's clearly this B. What we have to remember, though, is that inside opposite. So what number am I going to see in front of this x? 1/3, not the 3. So we're actually going to be looking at this.
Why is it 1/3?
Because horizontal inside opposite, this is literally tripling your x values. So what we have on the inside is the opposite of multiplying by 3, dividing by 3.
Oh, like the same thing with the -3. Like
It's exactly. It's the opposite effect.
All right.
So we're going to have that on the inside. Great. Vertical dilation. Vertical inside or outside, class?
Outside.
Thank you, 2 people. Everybody, come on. Inside or outside for vertical? Outside. Where is everyone today? Vertical outside. Vertical outside, same. So dilation, is that the multiplication or is it this addition?
Addition. Multiplication.
It's multiplication. Adding and subtracting are always shifting. Just like how this is a multiplication, all dilations are multiplications. So it's vertical outside, same. That's going to put a 2 on the outside. Now we already had that 1/3 on the inside. So it's not red anymore because I'm showing you what changed. And then lastly, vertical translation by 5 units. We were already told that A, B, and C are positive. We've already found A and B. That forces C to be 5. There it is. So if you would like to know, and by the way, this is how you find G of x. If you would like to know what G of -6 is, you just drop a -6 right there. Two times f of whatever 1/3 of -6 is. And then plus 5. Okay, well 1/3 of -6 is -2. So here's what this says. 2 times f of -2. And if you would like to know what f of -2 is, just come up here to the table. Because this has selected values of f. From this table, and it'd be great if lots of voices shouted out, not just the 2 in the front that are brave. What is f of -2 according to the table?
12.
It is 12. Here is f of -2. So this actually says 2 times 12 plus 5, 29. Ta-da! Isn't that fun? Yes, ma'am.
So dilation is just multiplication from division?
Well, just multiplication. We technically don't say division. We either are multiplying by a number bigger than 1 or multiplying by a number between 0 and 1. Because all negatives are reflections. But yeah, so anytime you multiply by a value, and don't worry about positive or negative because it has to always be positive because negative is its own thing. Anything between 0 and 1 makes objects smaller. Anything bigger than 1 makes objects bigger. But we don't do any divisions. We do multiplications only. Because there's really not a difference between multiplication and division. You know, you say divide by 2, and I would be like, oh, you mean times 1/2? Because it's the same thing. Okay. But all dilations are a multiplication, yes. Are we cool in the gang with that question? That question stands out as a very AP-ish question to me. It seems very on par with the kind of things that the AP exam is going to ask of you. And on the back, what we get here is some good old-fashioned, essentially, review of rational functions that we've already tested on. It's just now looking at it through the eyes of transformations. Here we have some f of x. Now we don't have its equation. We don't have its equation yet. That's what part A is asking for. What we do have is an obvious vertical asymptote at x equals -2. There's also an obvious horizontal asymptote at y equals 0. I'm going to even write y equals 0 on there. You know what? I'm going to write x equals -2 on there also. Why not? The parent rational function, the parent reciprocal function is y equals 1 over x. Now this is clearly not 1 over x because 1 over x is a vertical asymptote at the y-axis, x equals 0. So how does this graph compare to the parent reciprocal function whose asymptote would have been x equals 0? Nobody sees it? What this thing's vertical asymptote would have been here. So what would I have to do to that to make it become what we actually have? Well, give me a direction. Go left 2. Yes. So we need to go left 2, shift left 2 units. But if you shift left 2, what is going to replace my x? X plus 2. So what we have here is f of x equals 1 over x plus 2. And if you would like to confirm that this is the equation, maybe there's a vertical stretch or shrink that you were unaware of. What you do to confirm that is you test a point that you can see. Let's check out our y-intercept. That's at x equals 0, right? If you plug in 0, you get 1/2. It looks like it's crossing through 1/2 to me. And because it's in the top right quadrant and bottom left quadrant, we know that there was no reflection, because a reflection would have put the curves in the opposite corners. So that's it. That is the equation. And there is no x-intercept because there's no way to make the top of this equal 0. Right? Everybody cool? That's not too crazy, right? Let's write down its domain and range. Domain is everything except for the number x equals -2. And the range is everything except for the number y equals 0. Boom. There it is. I want to do B and C not necessarily in the order that they're given to me. I want to kind of do them at the same time. I just want to be able to bounce back and forth between the two concepts, okay? Can I move the paper? All right, I just didn't want anybody to bug out if I move the paper. Okay. I think it's somewhat easier to talk about how these transformations are changing the graph before trying to use the transformations to sketch the graph. I want to talk about it in words. And I want to do this one first. What is that going to do to my graph? It's going to shift it right 4. But we're going to write it in the appropriate way. We're going to say horizontal translation or horizontal shift, whichever one you want to say, of 4 units. Now what that's going to do is it's going to add 4 to every single x value that this graph has. It's going to add 4 to every structure's x values, including the asymptotes. This asymptote's at x equals -2. If you add 4 to that, it becomes x equals +2. Now a horizontal asymptote is a y value, and x changes do not change y's. So that has no effect on my horizontal asymptote. It just moved everything that direction for now. Cool? All right. So that's why I wanted to do kind of both at the same time. Now, what does this negative sign do to my graph? You guys can just shout it out. Yes, that is a reflection, and since it's written outside, that is a vertical reflection, so reflecting over x-axis, which is also the same thing as saying reflect in the x-axis. I just want to make sure you hear those words. Reflect over x-axis. Now, I'm not going to draw anything because of that on my grid, but what I will draw is this. A little miniature representation with asymptotes. Reflecting over the x-axis just swaps the quadrants that we're in. Now we'll be in top left, bottom right once I do have my asymptotes on there. Now we've got this 2 on the front. Vertical outside, same. So this is a vertical, and because it's multiplication, dilation. Factor 2. What effect does that have on a graph? It multiplies all your y values by 2. So together, what effect do these two have? They multiply all your y values by -2. That's what they do, including this value. But if you multiply 0 by -2, you still get 0. So as of yet, my horizontal asymptote has been unaffected. So far, so good with that. Lastly, this one. Vertical outside, same. Vertical translation, 3 units. Shift up 3, right? So we've multiplied this number, 0, by -2, still got 0. Now add 3 to it. Now it's at y equals 3. Ta-da! There it is. And we know it looks like this. Now we could just slap 2 blue curves on there, or we could go a little bit further, do a little bit of review, and have a better sketch by tracking a couple points. What do you think? Want to track a couple points? All right. I've already mentioned the original y-intercept was at 0, 1/2, right? That was right here. Let's transform it according to these rules and see where it lands. First, shift right 4. Oh, okay, that means add 4 to this, so it's now at 4, something, right? The other 3, the things I wrote in green, they're only going to change the y values. Together, these 2 right here, this negative and this 2, says multiply your y value by -2. So you multiply this 1/2 by -2, you get -1. Then you add 3 to that -1, and you get +2. I know there's a coordinate at 4, 2. And all reciprocal functions are symmetric around their center. So if there is a dot that is right 2 down 1 from this intersection of the asymptotes, there is a dot that is left 2 up 1 as well. So that one's new y-intercept is at 4. Did that make sense how I knew that? I just went right 2 down 1, so its reflection would be left 2 up 1. And then you can just do something like that. You know, we could go even further. And we might as well, since it's good review, let's actually get the equation of this graph. From this. I know it didn't ask me to, but I'm trying to, stick all the concepts together for us. This says where you used to have an x, you need to drop in an x minus 4. So your g of x, where you used to have an x, you're going to drop in an x minus 4. There used to be an x on the bottom, but there is still a plus 2 there. This used to have a 1 on top. This says, no. You're going to multiply those y values by negative 2. All right, well, 1 times negative 2 is negative 2. And then shift up 3. So you can clean that up. I don't like negatives on the top of my fraction. I'm a fan of negatives on the front of my fraction. And x minus 4 plus 2 is x minus 2. There is the equation of our new rational function. And by the way, if you would like to find out where its y-intercept should have been, drop in x equals 0. And what you're going to get is negative 2 divided by negative 2, which is positive 1, plus 3, which is 4. So that's a lot of all the stuff put together. Last thing we need to do is state the domain and range. It's everything except for those red lines. So domain. Everything except for x equals 2. And range. Everything except for y equals 3. Feels good. Questions, comments, concerns before we move on to the last example, finally the last example of transformations. Everybody's cool with all of that? Okay. The last example, I feel like I've kind of already let the cat out of the bag. We're just going to be writing the equations for the vertical and horizontal asymptotes. And some people on the last test were confused by the test question that said write down the equation of the line that is the vertical asymptote, write down the equation of the line that is the horizontal asymptote. And then it realized that meant you were supposed to write x equals some number and y equals some number. That's all you were supposed to do. For quadratics, we found the vertex by saying what makes the inside equal 0, comma, the number to the far right. For cubics, we said, oh, you want to know where the inflection point is? What makes the inside equal 0, comma, the number to the far right? So that's still true. Okay, these things don't have an inflection point. They don't have a vertex. But what they do have is 2 asymptotes. What makes the inside equal 0? X equals h. Basically, what makes you divide by 0? Oh, and the number to the far right. Y equals k. Because this represents a horizontal shift, this represents a vertical shift away from x equals 0 and y equals 0. So all you have to do for the vertical asymptotes is tell me what makes the inside equal 0. And for a fraction written like this, it's what makes the bottom equal 0. Because you can't divide by 0. What makes the bottom equal 0? Positive 3. So you just write that the vertical asymptote is at x equals 3. You must write x equals, or it is not the equation of a line. What makes the bottom equal 0?
Negative 4.
Negative 4. X equals negative 4 is my vertical asymptote then. We're not describing the transformations. We're just saying what makes the bottom equal 0 for this one. 5. X equals 5 then. Someone last period was like, wouldn't these negatives cancel each other out? Well, kinda. The way it sits is a reflection of the x-axis, and this is showing you a reflection over the y-axis as well as a shift of some sort. But you could factor a -1 out of the bottom, just so you know, and it would look like this. And the -1 that's on top, technically there's a -1 times 2 there, and the -1s on the bottom would cancel each other out. So this thing is equivalent to 2 over x minus 5 plus 3. These are equivalent functions. Anyway, and this one down here, what makes the bottom equal 0?
12.
Positive 12, because you know you're not allowed to divide by 0. So x equals 12 is your vertical asymptote. Your horizontal asymptote is supposed to be y equals 0, so doing this is going to shift that horizontal asymptote up or down. So what's this one's horizontal asymptote?
0.
But it is important that you say
Y.
y equals, there it is. We must say y equals 0. How about this one? Y equals -5.
Oh, you keep it the same.
Well, yeah, because look, it's vertical outside, same. So if it's plus, it's a shift up. If it's minus, it's a shift down from y equals 0. So this one's going to be y equals -5. Yep. This one, y equals 3. And this one tripped up a few people in 7th period. Is this 4 negative? No, it is not. But some people said -4 anyway. But that number itself is not negative. You know what is negative? The fraction. That's just like this one, where there was a negative on the front. But that is a +4. And that, my good nerds, is the end of transformations. Thank God.